In today's notes, we're going to take a look at one of the most challenging things in this chapter. I know it's only day 2, but this is the concept that we have to talk about today. We're going to take a look at the difference between polar vectors versus what we've been talking about, which are rectangular vectors. Now, in order to help you understand the concept and the difference between the two, I'm going to try to put it in terms of giving somebody directions. So let's say you were in a city and you wanted to give directions for somebody of how to get from point A to point B. You might tell them, travel down this road east for 2 blocks and then make a left-hand turn and travel 2 blocks down that road, and then you're there. This is an example of how we tell people how to get from one place to another with rectangular coordinates. They have to follow pathways that are either horizontal or vertical so that we can be moving in either the I direction or the J direction. So you'd move X units in the I direction and Y units in the J direction. And this is what comprises a rectangular vector. But let's take a totally different look at that same scenario of getting from point A to point B. But let's pretend that you didn't have to follow the streets. Let's say that you were a bird and could fly over the top of all the buildings. This, going 2 units to the right and 2 units up, would probably not be the pathway that you would take to get from point A to point B, since it's much longer to travel that. What you would probably tell somebody is travel this far in this direction. And this is the idea of a polar vector. You tell me how far to travel away from where my starting point is, and that's the L that you see in this picture, your total length of travel. And then you give me a directional angle, theta, of where exactly you want me to end up. And that theta starts at 0 degrees pointing straight to the right. And remember, positive angles are measured counterclockwise. So if you give me an angle, for example, like 45 degrees, that would take me into the first quadrant. But you don't have to stay in the first quadrant. If you want me to travel left and up, you'd give me an angle between 90 and 180. If you wanted me to travel left and down, that would be over 180, but less than 270, et cetera, et cetera. That directional angle could be any measurement that would take me around. So basically, the way that you could think of polar coordinates as a series of concentric rings, 1 unit away from the starting point, 2 units away from the starting point, 3 units away from the starting point, et cetera. And you tell me how far to travel, and then you tell me what directional angle to rotate at to get to where you want to go. So now let's take an enlarged look at exactly what is going on and the difference between rectangular vectors and polar vectors. Again, in a rectangular vector, they're going to tell you a certain number of units to travel in the X direction, so A units in the I direction, and a certain number of units to travel in the Y direction, B units in the J direction. Polar vectors just want to give you the total length to travel and the directional angle to rotate at to get to where we want to go. These two ways of expressing vectors should be able to accomplish the same goal. So remember, polar vectors give you a total distance of travel, L, and an angle measured from the positive x-axis called theta. These are the kinds of vectors that you're usually going to get in physics. They'll say something like a 10 Newton force acts at a 62-degree angle, et cetera, et cetera. They're giving you polar vectors. The trouble is the math with polar vectors is very difficult. As we learned yesterday, working with rectangular vectors was very easy. So one of the things that we're going to want to be able to do is to be able to convert back and forth between polar vectors and rectangular vectors. So to do that, we have to understand that polar and rectangular vectors are related through some very simple right triangle trig. If you take a look at this blown up picture right here, in relationship to where theta is, B is your opposite side, A is your adjacent side, and L is your hypotenuse. So we can relate all of this information through basic sine and cosines using just right triangle trig. Okay, so let's take a look at an example of going from polar vector to rectangular vectors. Let's say somebody gives you the following vector. vector v equals 13, 62. First thing you want to do is you want to recognize right away that this is a polar vector. They're giving you the total length of travel, L, followed by a comma, followed by the directional angle that we're supposed to be rotating at. So 13 is my L, and 62 is my directional angle. We can even draw this picture out. So we want to travel a total of 13 units at an angle of 62 degrees from the x-axis. So here's your picture right here for this vector. And our objective is we're going to try to convert that into a rectangular vector. So we're trying to figure out how many units to travel in the x direction and how many units to travel in the y direction. So what I'd like you to do is imagine dropping a line straight down from the tip of this vector to the x-axis. The horizontal distance is your a value, and the vertical distance is going to be your b value. And in this right triangle that you've now created, that means b is your opposite side, and a is your adjacent side, and of course the 13 is your hypotenuse. So let's use some basic right triangle trig here. We know that sine of an angle is supposed to be made of the opposite side divided by the hypotenuse, and the cosine is supposed to be made of the adjacent side divided by the hypotenuse. So if we were to take these two formulas and multiply through both sides by hypotenuse, you would figure out that your opposite side, which is going to be your b value, is going to be hypotenuse times sine. And your adjacent side, which is your a value, is going to be hypotenuse times cosine. And remember, the hypotenuse was the total length that you know, and the angle is also something that you know. So, in general, the way that you would figure this out is your a value would be 13 times the cosine of 62 to help you get the adjacent, and your b value would be 13 times the sine of 62. So I did the actual math here. If you're going to do this on your calculator, don't forget you're going to want to be in degree mode. This is approximately 6.10, and this is approximately 11.48. So your vector then would be this many units, 6.10, in the I direction, and 11.48 units in the j direction. That's rounded off. So in general, so if you want to do this in general, your formula for taking a polar vector and converting it into a rectangular vector is length times the cosine of the angle in the I direction plus length times the sine of the angle in the j direction. So it's a very straightforward conversion to go from polar to rectangular. Just follow this plan. So I've got one more example for you down here. I'd like you to convert the vector u, which is currently in polar form. There's our total length. There's our directional angle. I'd like you to take this vector and get it into rectangular form. U, following our plan that we laid out above, is going to be equal to L times the cosine of the angle in the I direction plus L times the sine of the angle in the j direction. So for us, that's going to be 35 times the cosine of negative 37 degrees in the I direction, and then add that together with 35 times the sine of negative 37 degrees in the j direction. Now again, when you plug this into your calculator, make sure you're in degree mode. The final answer for this should turn out to be 27.95 in the I direction and minus 21.06 in the J direction. Now, this actually makes sense because remember, an angle of negative 37 degrees is going to take you into quadrant 4, and quadrant 4 has you moving to the right and then down, which is what the I's and the J's are showing me here. Now that we understand how to go from polar to rectangular vectors, let's take a look at going back the opposite way. So if I give you a rectangular vector, how do we get ourselves back to polar form? This is a little bit harder, and it's only harder because of the limitations on our inverse trig functions, which we'll talk about in a moment. But let's say you're given the following vector. V equals 2 units in the I direction plus 4 units in the J direction. So this is a rectangular vector. And we'd like to get ourselves into polar form. So we'd like to know the total length and the directional angle. So again, I'm going to start by mapping this out. I'm going to draw a picture. So we're going 2 units to the right, and we're going 4 units up. So they're giving us those directions in terms of rectangular coordinates. So the first thing I have to try to do here is I have to try to find my total length. And that's the hypotenuse side of this right triangle. The total length is going to be found just by using Pythagorean theorem. So we're going to take the square root of the horizontal leg, so 2 squared, and add that together with the vertical leg squared, so 4 squared. So here my total length turns out to be 4 plus 16, which is 20, underneath the radical. And of course, you're going to simplify that for me, so that's going to be 2 radical 5. Now, the next thing that you're going to have to do is find your directional angle for me. Now, the angle that we're looking for is using 4 as its opposite side and 2 as the adjacent side. And the trig function that we know that uses opposite and adjacent sides is tangent. But what we're looking for is what the angle is. So remember, whenever you're asking what is the angle that has this information, you want to do inverse tangent. So we'll be doing inverse tangent of 4 over 2 because tangent is made of opposite over adjacent. So we got to put the 4 on top and the 2 on bottom. And my calculator, when I type this in, again, make sure you're in degree mode, is going to give you 63.43 degrees. So putting this all together, my vector in polar form is going to be 2 radical 5 for the total length, and then a comma, and then you tell me the directional angle, 63.43 degrees. This would be the answer for this problem. Now there's one thing that you have to be very, very careful of, and that is the limitations on inverse tangent. If you think back to our previous chapter when we talked about inverse trig functions in chapter 4, we learned that inverse tangent can only give you angles between negative 90 degrees and positive 90 degrees. So these are the limitations for inverse trig. That doesn't take you all the way around the circle, so that's a problem. So what you have to do when you find your angle by using inverse tangent is you have to make sure that it matches the correct quadrant. Otherwise, what your inverse tangent is giving you is a reference angle. So negative 90 to positive 90 degrees can take me anywhere on the right-hand side of the y-axis. So basically, that's quadrant 1 and quadrant 4. But if your vector is traveling to the left, either into quadrant 2 or into quadrant 3, your directional angle is not going to match because inverse tangent can't do that for you. So you'd have to add whatever angle you're being given with 180. So in general, to turn a rectangular vector, A units in the I direction plus B units in the J direction, into polar form, you're going to use the magnitude formula to find the total length and inverse tangent with the Y direction over the X direction to help you find the directional angle. I put a little asterisk here because remember, be careful of making sure that inverse tangent's giving you the correct quadrant. So we've got one last one that we're going to do together here. Let's try to convert a vector u, which is negative 5 units in the I direction plus 3 units in the j direction, into polar. Finding our total length is going to be negative 5 squared plus, I should put this in parentheses, plus 3 squared, all underneath the big square root, which is going to be 25 plus 9, in other words, square root of 34. And our directional angle is going to be found by taking the inverse tangent of the y-coordinate, which is 3, over the x-coordinate, which was negative 5. Now here comes the tricky part. What your calculator is going to tell you for the directional angle is negative 30.96. Now let's stop and think about this angle for a second. Negative 30.96 is in quadrant 4. That would be going down to the right and down. But if we look at our vector, we notice that's not what it's doing. This vector is going left and up. So what we're being given here is actually a reference angle because it doesn't match the quadrant that our vector actually is in. Our vector is actually in quadrant 2, left and up is quadrant 2, and the angle we're being given is quadrant 4. So we're 180 degrees diametrically opposed from where we're supposed to be. So the actual angle theta would be 180 plus this, which is going to be 149.04 degrees. So finally, let's take a look at what would be the most complicated thing to do here, and that is how to add or subtract polar vectors. In your physics classes, this is when you would use the tip-to-tail method, which again, as I mentioned at the beginning of this, leads to inaccuracies due to possibly you're measuring your protractor a little bit off or measuring using your ruler just a little bit off. What I'm about to show you will be exactly precise mathematically. So let's say you're given these two vectors. Vector u is 5 comma negative 37 degrees and vector v is 8 comma 65 degrees. Notice both of these are in polar form right now because we have a length and directional angle for each. The easiest way to perform the addition of vector u and vector v would be to actually convert both polar vectors into rectangular form. That's going to make your job of adding the components together really simple. So let me show you what that looks like. For vector u, you would do 5, which is your total length, times the cosine of the directional angle in the ith direction, and 5 times sine of the directional angle in the j direction. So that would give us 3.99i minus 3.01j. I just used my calculator to get me these two values. We would do the same thing for vector v, but its length is 8 and its directional angle is 65. So 8 cosine of 65 degrees gives us the I, 8 times the sine of 65 degrees gives us the j. And that turns out to be 3.38i plus 7.25j. Now all you have to do, if somebody wanted you to find what the answer to vector u plus vector v is just add together the i's. So that's going to give us a total of 7.37i, and then add together the j's. And that's going to give us 4.24j. It becomes super simple if you break it down into its components. Now let's say you were doing this in your physics class and your physics teacher says, well, I want that answer as a polar vector. What do you do then? Just convert that answer back to polar form, as we mentioned before. Again, be careful with inverse tangent. Make sure the angle you're getting matches the quadrant that you're supposed to be in. So since my i's and j's here are positive, that means we're in quadrant 1. And that is a quadrant that inverse tangent could give you the answer correctly. It would not be a reference angle, it would be the correct answer. Okay, you are now ready to try the homework for tonight.